Review for 6.1 and 6.2. The first question, we're going to draw two equivalent graphs. Remember that equivalent means that they have the same connections, the same vertices. So I'm going to draw one that has 5 dots here, and I'm going to label those A, B, C, D, E, because those are the 5 vertices. And then I'm going to draw another one that has our dots in a line. Okay, yours may look different from this, which is totally fine. So A, B, C, D, E. So my first connection, right, the edge is AB. So I'm going to connect AB to both of these. Then I have BC, so I'm going to connect BC together. Then I have CD twice, so that means that I have parallel path or parallel edges. So CD and CD, so parallel edges. And then CE, that's going to bring this over here. That's going to bring this over here. And then DE, so DE and DE. So both of those are equivalent graphs. They look different, but they have the same vertices and they are connected the same way. All right, for the second one, draw a graph that models the bordering relationship amongst the should be states shown in the map. Use vertices to represent the states and edges to represent common borders. Okay, so on this one, again, you're going to create a dot to represent each one, and it doesn't matter what your pattern is. So I'm doing Washington, Idaho, Montana, Wyoming, Utah, Nevada, California, Oregon. So Washington, Idaho, Montana, Wyoming, Utah, Nevada, California, and Oregon. Okay, so all of them are represented. And so the key to doing a map like this is that you are going to start with one and then continue out from there. So I'm going to start with Montana. Montana is connected to Wyoming and Idaho. So Montana is connected to Idaho and Wyoming. So I've got those done. Then I'm going to look at Wyoming. Wyoming is connected to Montana, which I already have, and then it's connected to Idaho. So Wyoming is connected to Idaho. Oh, hang on a second. That was not what I wanted. That's not the connection I wanted. Wyoming is connected to Idaho, which is here. So Montana and Wyoming. Okay, we're good. Then I'm going to look at Idaho. So Idaho, we already have it connected to Montana and Wyoming. We also, and that's it. Oh, nope, we've got Washington. So it's connected to Washington. It's connected to Oregon. So we have that, Oregon. It's connected to Nevada. So we have Nevada here. It's also connected to Utah. Goodness gracious. So there we go. So there's Idaho. And then let's go for Washington. So looking at Washington, that's connected to Idaho and connected to Oregon. So we need to connect that with Oregon. Let's take a look at Oregon. The only connections we need there are to California and to Nevada. And then we look at California. That is connected to Oregon. We've got that already. And we need to connect that to Nevada. So that's connected to Nevada. And then let's look at Nevada. That's connected to California, which we already have. Idaho, Oregon, we do need to connect it to Utah. So Nevada's connected to Utah. Utah is connected to Idaho, which we already have. Is connected to Nevada, which we already have. And it's connected to Wyoming. It looks like we missed that when we were at Wyoming. Okay. So now we have all of our mapped out states and borders. Draw all simple graphs with 5 vertices, A, B, C, D, E, and 5 edges, one of which is AB, another that's CE, another AC, and another that's ED. All right, so I'm not sure how many graphs this is going to take. So I'm just going to draw multiple graphs here, and we'll label them in a second. So 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And let's do one more just in case. All right, so I don't know exactly how many we're going to need here. We're both doing this together. So A, B, C, D, E. Go ahead and fast forward this because it's going to take a bit here for me to label all of this. A, B, C, D, E. 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 And again, I may have more than I need, but we'll see when we get there. All right, so let's take a look at this first one. We have AB, so that's going to be a connection on all of them. So AB is to be connected on all of them. So I'm going to get those done. AB and AB. Then CE is going to be another one. So CE is connected on all of them. CE, 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 and CE. Then we have AC. So AC is connected on all of these. And ED, ED. Okay, so those are the ones that are guaranteed. So the question actually says draw all simple graphs. Remember, simple graphs are not going to have parallel edges and they are not going to have loops. With 5 vertices, we already have those vertices mapped out, in 5 edges. That's not really normal. Usually we have 4 edges, but we're good. One of which is blah, 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 blah. So we have all those. So we're going to draw all the simple graphs. I'm going to stick this in a different color. So I'm going to put it in green just so it stands out a little bit. So, in fact, let's see if there's a brighter green. That might be easier. Okay, so I know that I can put an edge right here, which would be A to E. And let's look at anything else we could connect with A. We don't have A connected with D, so I could do that. A is already connected to B. It's connected to C. We connected it to E and D, so we're in good shape with A's. Now I'm going to look at B and see what that's connected to. So we could connect it to C. We could connect it to D, or we could connect it to E. So those are some options there. Do you get the idea of what we're doing? I'm first tackling just one at a time, just like I did with the states. And then on this one, I already did C. I don't have C and D together. So I'll put C and D together. That will work. And then C is already connected to E and A, and I think I had B connected to it. Yep. So now I'm looking at D. Did we have A and D connected? Yep. A and D we had connected. And B, did we have B and D? Yeah, we had B and D connected. So I don't know that we have any more. Stop me if I'm wrong, but I think we've got pretty much everything we could possibly have. So B and E, B and D, C and D. We already have C and B. Yeah, I think that's it. 1, 2, 3, 4, 5, 6. I think that's all we need. I don't think we need these other ones. So we can go ahead and erase these. If you happen to find one that I missed, please let me know. We want to make sure you guys are all good. All right, draw a complete bipartite graph for K45. Remember, I'm going to put that, the 4 on the one side. 1, 2, 3, 4. And then I'm going to put the 5 over here. 1, 2, 3, 4, 5. Well, those 5 aren't spread out very evenly, so we're not going to have quite the nice graph. All right, so I have 4 in this column, and I have 5 in this column. And the idea is, remember we talked about speed dating. This is going to be all the 4s have to connect with a unique 5, or from the row 5. So I'm going to connect here. I'm going to connect to this one. I'm going to connect to this one. I'm going to connect to this one. And then I'm going to connect to this one. So those are the ones coming from that first one. Then I'm going to connect the second one to all of those same dots. Move that here and then down here. Then I'm going to connect that third one to all these dots. So I think you get the idea. It's just making sure that each one on one side is connected to the other. Again, sometimes it's, oops, that didn't quite come across the way I wanted it to. And then I have one coming down here. And then the last one, I'm going to connect it here, and then here, and then there, and there, and then there. Okay, so that would be a 4-5 bipartite graph complete. In problems 5 through 8, use the following graph. Find the degree of each vertex. Okay, degree of each vertex. I'm just going to go ahead and list them. So A, B, C, D, E, F. Oh, nope, we just have E. All right, let's get these. A has 1, 2, 3, 4, 5. B has 1, 2, 3, 4. C has 1, 2, 3, 4, 5. D has 1, 2, 3, 4. And E has 1, 2. Okay, so those are our degrees for each of those. Use the vertices to describe 2 paths that can start at vertex, we don't have R, let's say E. Okay, start at vertex E and end at vertex A. Okay. So if I start at E and I end in A, the real easy one would be to go ahead and go from E to C to A. So E, C, A. Another route might be E to D to C to B to A. Okay, it's a little bit more roundabout, but I could do it. So that was E, D, C, B, A. So there's lots of different ways that you can create a path. Now remember, we're not talking about Euler's path. We're just talking about a regular path. Use vertices to describe a circuit that starts at vertex B and passes through C. All right, let me erase this here. So a circuit, not an Euler circuit, but a regular circuit, is a closed off section. So an easy one would be B to C, C to A, and then A to B. And that would give us a circuit. So B, C, A, B. Your key to a circuit is that it's going to start and end at the same one, right? Let's see here. Let's do another one. We could do B to C. So B to C to D. And then we could go this route to B. Okay, so that would be another circuit. All right. List the adjacent pairs. Let's go ahead and look at the adjacent pairs. Again, we start with, I'm just going to list them over to the side here. We start with A, And so we have, erase this real quick. We have AC, and then A is also connected to B. And then there is a loop, right, from A to A. Let's look at B now. B we already have connected to A. It's also connected to C. It's also connected to D. Now let's look at C. We have it connected to A and we have it connected to B. It's connected to E and it's connected to D. And then let's move on to D. We have it already connected to B and C. We do not have it connected to E. So those would be our pairs. And then, of course, you have the AA loop. Okay? Our adjacent pairs. There's page 1 of our study guide, and we'll take a look at page 2 in a moment.